Great day, everyone. Concentrating on arithmetic and geometric sequences, exercises on definitions and examples in preparation for an evaluation activity. So we start by recalling what is an arithmetic sequence and what is a geometric sequence. When we say arithmetic sequence, let us remember that this is characterized by a common difference between consecutive terms, and we make use of the formula a sub n is equal to a sub 1 plus the common difference multiplied by n and 1. While for a geometric sequence, this is characterized by a common ratio between consecutive terms, and we make use of the formula a sub n is equal to a sub 1 multiplied by the r raised to the n minus 1. So let's start with the exercises. Answering the question, is the sequence an arithmetic progression or arithmetic sequence, or a geometric progression, GP, or a geometric sequence, or neither? If your answer is AP, follow the instruction. Tell the common difference and give the next term. You also have to determine the equation that fits the given sequence. If GP, tell the common ratio, give the next term, and also determine the equation that fits the sequence. While if you think that the sequence is neither arithmetic nor geometric, then you tell N. Let's start with the first example. First exercise. We are given the sequence 5, 15, 45, 135. What will your answer be? And the answer is, it is a GP with a common ratio equivalent to 3. How did we get 3? Again, let us take note that we go from the right to the left. And when we go from the right to the left, and this is geometric, that would mean to say we divide. 135 divided by 4, 45 is equal to 3. Then we have 45 divided by 15, we also have 3. Then 15 divided by 5, we also have 3. Thus, cementing our claim that r is equal to 3. Then we also have to take note that we have to give the term after 135. So since we are going from the very last term, we are moving to the right, then we make use of the operation multiplication. So we say 135 multiplied by 3 will be giving us 405. Thus 405 is the term after 135. Let us also establish the equation for this sequence following the format a sub n is equal to a sub 1 multiplied by the r raised to the n minus 1, substituting whatever is given. So we have a sub n is equal to 5, which is our very first term, and 3, which is the common ratio. And we raise the common ratio to n minus 1. Now take note that you cannot multiply 5 and 3, considering that 5 is a base raised to the exponent 1, 3 is also a base with an exponent n minus 1. So two different bases cannot be combined together, leaving the formula to be a sub n is equal to 5 multiplied by 3 raised to the n minus 1. Next sequence, we have negative 4, negative 8, negative 12, negative 16. What would this be? Is it an AP or is it a GP? And your answer? If you said AP and the common difference is negative 4, you're absolutely correct. Again, we go from the left to the right. So just recalling our operations on integers, we have negative 16 minus a negative 12. Subtraction means you have to do the opposite. That becomes negative 16 plus 12, giving us an answer of negative 4. And likewise, when you say negative 12 minus a negative 8, that would also give us a negative 12 plus 8, giving an answer to given an answer also of negative 4. And then the last one, when we say negative 8 minus a negative 4, that would still give us a negative 4, giving us a common difference of negative 4. Then what will be the term after negative 16? And since we again are moving from the right to the from the left, we are now moving to the right. Then, and this is an arithmetic progression, therefore we use addition this time instead of subtraction. So we say negative 16 plus a negative 4, which is the common ratio. We are adding two negative numbers, so we say the answer is negative 20. So negative 20 is the term after negative 16. Then, we set up the equation by following the format. A sub n is equal to a sub 1 plus the common difference times the difference of n and 1. Substituting whatever is given, you have here the negative 4 is the first term. That is our first term. And the common difference is also a negative 4. That's where we got the negative 4 here. Then we multiply by n minus 1. We have to follow the GEMDAS rule. For the set of grouping, of course, we cannot simplify n and 1. So we proceed to multiplication, making or multiplying our negative 4 with n. That will give us a negative 4n. And multiplying also a negative 4 times a negative 1, resulting to a sub n is equal to negative 4 plus negative 4 times n is a negative 4n. Negative 4 times a negative 1 is a positive 4. And you can see here that we have a negative 4 and a positive 4, which may be simplified. Negative 4 plus 4 is 0, giving us the final formula to be a sub n is equal to negative 4n. That's the formula for this given sequence. Next, we have a negative 12, 6, negative 3, 3 halves, and negative 3 fourths. Again, observe what you are given. You have alternating negative, positive, negative, positive, negative. So no way will this be an arithmetic sequence, because if it would be an arithmetic sequence, it would be negative going positive or positive going negative. It would not be alternating. So what you can check is this a geometric progression or is it neither? Go. And the answer is, it is a geometric progression with a common ratio of negative 1/2. So how are we going to get the common ratio to be a negative 1/2? Let's see. We have to recall that we have to divide again negative 3 fourths. We divide that by the previous term, which is 3 halves. So dividing fractions, what's the rule? Dividing fractions, easy as a pie, flip the second and multiply. So this is 4. Thus, we can say 3 divided by 3 is 1. And we have 2 is divisible by 2. Likewise, 4 is divisible by 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. Thus, we are left with negative 1 times 1 is a negative 1, and then in the denominator, 2 times 1 is 2. Let's also check. Negative 3 halves of positive 3 halves, and we are going to divide that by a negative 3. So likewise again, flip the second and multiply. This will become 1/3. And we can see that we can divide 3 and 3. We arrive at 1. So again, we have, this is negative by the way. So positive times negative is negative. 1 divided by 2 is 1 half. And moving on, you have negative 3 divided by 6. And that would still be equivalent to a negative 1 half. And likewise, you have here 6 divided by negative 12. Positive divided by negative is negative. And 6/12 is actually written also as 1 half. So thus, we have here a common ratio which is equivalent to negative 1 half. We also extend from negative 3/4, what would be the next term to it? And inasmuch as we are moving again from the left, we go to the right, we multiplied negative 3/4 by a negative 1 half, which is the common ratio. Thus, we say negative times negative, we have a positive, and we have 3 times 1 is 3, 4 times 2 is 8. The term after negative 3/4 is 3/8. What would be the equation for this sequence? Again, we make use of the generic formula. A sub n is equal to a sub 1 multiplied by the r raised to the n minus 1. Doing substitutions, our a sub 1 is negative 12. That is why we have a negative 12 here. The common ratio is negative 1 half. Again, do not forget to enclose your common ratio, especially that it is negative and it is a fraction. Thus, it is very important to enclose that in a set of parentheses. Then we raise that to n minus 1. Take note that you have a negative 12 and you have a negative 1 half. Also, these are two different bases. Thus, we leave the equation to be a sub n is equal to negative 12 multiplied by negative 1 half raised to n minus 1. That's for the third example. What about for the fourth example? Still on AP, GP, or neither? Let's deal with the first one first. And the answer is already given. I'm sorry for that. So we have here 2, 1 half, 4, and 1/4. So observe what you are given. 2, then it became 1/4, so it decreased. Then it became again 4, it increased. Then it became again 1/4, it decreased. So this will not be an arithmetic sequence. There is no way that you can come up with a common difference. If you are also going to check whether it is a geometric sequence, take note that negative 4, or sorry, you have 1/4, you are to divide this by by 4. So if you're going to divide that by 4, flip the second, multiply, your 4 will become 1/4, and that would be equivalent to 1/8. And you will see that if you would also take 4 and you divide that by 1 half, flipping the second and multiply, you have 4 times 2, which is equivalent to 8 and not 1/8. That is the reason why the answer is neither. Then we have the next one. We have here figure numbers, dots. Take a look at this. Will the dots be forming a geometric progression, or will the dots be forming an arithmetic progression? I'll give you time to think about the answer. Your answer is, let us see. Give first, of course, the sequence that represents the dots. We have 1, then 3. Counting the next, we have 5, then 7, we have 9. So, what was the answer? It is an AP, and the common difference is 2. Again, how did we get the common difference? 9 minus 7 is equal to 2. 7 minus 5 is equal to 2. 5 minus 3 is equal to 2. And 3 minus 1 is equal to 2. We likewise give the formula. By the way, what is the term after 9? That would be 11. Now let's set up the formula, substituting whatever are the necessary information. So our a sub 1 is 1. Thus, we have here written 1. The common difference is 2 there. And we have multiplied by n minus 1. Again, we multiply 2 times n and 2 times negative 1. Thus, what will be our answer here? We have a sub n is equal to 1 plus 2 times n is 2n and 2 times negative 1 is negative 2. We can again simplify 1 plus a negative 2, arriving at an answer 2n, then 1 minus 2 is negative 1. So the final formula for this set of dots is equivalent to a sub n is equal to 2n minus 1. So that would complete our short exercise on determining whether a sequence is AP, GP, or neither, extending the sequence, and also determining the formula that fits the sequence. So at the end, can you check yourself and say, I can determine whether a given sequence is arithmetic, geometric, or neither? Can you also say that I can write the formula given the list of either arithmetic or geometric sequence? If your answer is for both question are both yes, then you are ready for the next exercise, part 2 of this particular topic. If not, you can still go back again for this video, rewatch, and see to it that you understand everything. See you in the next video. And again, thank you for listening. Thank you for watching.